In this session, we're going to be looking at developing web applications, so web services, whether that be GraphQL or REST, using the Go programming language and MongoDB. So there's going to be a lot of stuff that we're going to cover, but by the end of it, you should have some familiarity when it comes to developing your own web services. Now, before we get too invested, I want to tell a little bit about myself. So I'm in developer relations at MongoDB. I'm a developer advocate. I have my own personal blog called The Polyglot Developer. I organize a local tech meetup in my local tech community. I'm just an overall technology enthusiast, and I am a video game enthusiast. So that's kind of my background when it comes to how I'm involved with tech. Now, let's jump right into the core material of this particular session. So the agenda, first we're going to start by deploying clusters to MongoDB Atlas. We don't have anything to work with as of yet, so we need to deploy something so that way when it comes to developing our Go application, we have something to communicate with. Once we have that cluster deployed, we're going to connect to it using the Go programming language. And once we're connected, we're going to be looking at different operations when it comes to CRUD. So create, retrieve, update, and delete. These are all common operations when it comes to a database, and that will lead us into actually developing a REST API or even a GraphQL API, because we're going to be using the CRUD foundation that we learned in a previous slide, and we're going to apply it towards something real. So I'm going to show this slide now. I'm also going to show it towards the end of this particular presentation. But if you go to cloud.mongodb.com, it doesn't cost anything to get started with MongoDB Atlas. But if you want a more powerful cluster, something that is a little more extravagant than what's in the free tier, I am offering a $200 credit towards your account. It's for new and existing customers, as long as you haven't already applied this particular promotion code. So if you haven't, just go ahead and apply it. NickRaboy200, you'll get $200 credit. Again, it's not absolutely necessary. You can get started with a free tier account, but if you want something more, it's definitely beneficial. Now let's get started with deploying clusters using MongoDB Atlas. So let's get started when it comes to deploying that MongoDB instance. So the first step, after you log into cloud.mongodb.com, you're going to want to deploy a cluster, and you're going to be presented with three options. Do you want to deploy it to AWS, Google Cloud Platform, or Microsoft Azure? Now, it's totally up to you which you want to choose. You're going to get the same kind of environment, the same kind of dashboards. Everything's going to be the same regardless of what you choose. Some common circumstances on why you might choose one or the other. So for example, maybe all of your web applications or your entire organization is hosted on Microsoft Azure. In that circumstance, it might make sense to also host MongoDB on Azure, because now the database is closer to the rest of your web applications. It doesn't have to be that way, but that's a common circumstance. After you go through this small set of instructions and choose where you want it hosted, you're going to be presented with the MongoDB Atlas dashboard. It's going to look something like this. You're going to have just an empty cluster. So what you're going to want to do is you're going to want to create collections for that cluster. And this could be created inside of the dashboard. This could be created inside of the code. We're going to actually worry about that inside of the code rather than the dashboard. But after looking at this dashboard, the next step is going to be, well, what's your network safe list going to be? So by default, MongoDB Atlas is going to deny connection to everyone. It's going to be super locked down and sandboxed. So you're going to want to choose which IP addresses are allowed to communicate with your database. Now, on my screen here, this is kind of like a wildcard IP address. So this means that anyone will be able to interact with the database. In a production environment, you probably don't want to use this as your safe list IP, because you generally don't want the whole entire world to be able to communicate with your database. In a production environment, you're probably going to want to use the actual application server's IP and add it to this list. But it's totally up to you what you want to choose. Once you have your safe list in place, you're going to want to create a user account. So the user account, you'll be assigning it a username and password. You're also going to determine which databases or what they have the ability to do. Do they have read access, write access, both? Chances are you're not going to want to give them an Atlas admin if you're going to be using this account inside of your application. You want to be able to give this account exactly what they'll be doing when it comes to your application. So if you're creating a user account for application X, well, don't let them access database Y as well. But it's totally up to you on how you want to design your database access rules. So definitely read through the documentation and see what makes the most sense for you. Now, let's take a look at that data model. So we want to determine a kind of data model to be used for the rest of this particular presentation. So we're going to be looking at podcasts and podcast episodes. So for example, this is one possible design when it comes to a podcast data model. So let's say that this is a podcast show. This isn't an episode. This is a show that encapsulates multiple episodes. So as an ID, it has a title, an author, and an array of tags. Not the most complex document, but it is bson, so it's similar to JSON, and you can model it much more complex than I have here. Now let's take a look at an episode document. So let's say that this is a second document that exists in maybe an entirely different collection in MongoDB. So this, again, has an ID, not related to the previous slide. It has a podcast field. So in this circumstance, the podcast field would be related to the podcast that we saw in the previous slide. So that 1, 2, 3, 4 might represent an ID. We have a title for the episode, a description, a duration. Again, not the most complex document. So let's look at a different way to model these documents, and it's totally up to you what you choose in the end. Let's say that we want to model our documents like this. Maybe we want to kind of embed them into a single document. So let's say that maybe our upper level of our particular document is the podcast show, and then inside of that document, inside of an array, there's an array of episodes where each item in that array, each object, is going to be a podcast episode. We could easily have everything inside of a single document. That works perfectly fine. We can also do it this approach. So maybe we want to continue down that one kind of document model approach and not have two collections. We have an episode, and every episode has the underlying podcast information in it. So this is another approach that you can use when it comes to modeling your MongoDB documents. We're going to be using the first two approaches for this particular session. So we're going to have two separate documents that exist in two separate collections. So we're going to have a podcast document and an episodes document. Don't let that stop you from being creative on your own. Inside of MongoDB Atlas, it might look something like this. So pretty similar to what we saw in the previous slides. And you don't have to use MongoDB Atlas when it comes to exploring your data. You can use the command line, you can use MongoDB Compass, but we're keeping it easy on ourselves. We're actually going to just use MongoDB Atlas Data Explorer as well as whatever we see inside of our code. Now that we have a cluster to work with, now we want to connect to that cluster using the Go programming language and the MongoDB Go driver. So the first thing you want to do after creating just an empty project file in your Go path is you're going to want to install the MongoDB Go driver. And there's plenty of ways to install it. You could use dep, you can use Go modules. There's probably other ways as well. This particular slide uses dep. So what we would do is we would say dep ensure add, and it would add this particular Go driver, which would be the MongoDB Go driver. Once it's added, then we can connect to our instance. So for example, we define a timeout, we say mongo.connect, and we provided the context with that timeout, and we also provided any options, which in this case, we provide the URL to Atlas. So in this example, I'm saying os.getEnv, which would be an environment variable on my machine or up in the cloud. And that would be the Atlas URL that includes the username and password, my unique URL string, anything that's part of that particular URI. If there's any kind of error, we're going to panic and end. Otherwise, we are going to wait until the function terminates and then defer to disconnect this particular MongoDB client. So that would connect to MongoDB Atlas, or even a locally installed instance of MongoDB. We can confirm that we're connected by doing a ping. So if we wanted to, we can say client.ping. We would do a ping. If we got an error, that means that maybe we weren't connected and we would panic. Otherwise, we're good to go. There's also another way that we can do business to see if we are connected. So for example, maybe we want to list all of the available databases that are on this cluster. So we've connected, we're saying client.list database names. This returns a slice of string. We're saying bson.m empty brackets. I'm going to get more into that in the next few slides, but essentially we're saying get all of the available database names. If there's an error, print it out. Otherwise, print out this slice of string. Now, that was pretty easy. We're connected to MongoDB Atlas using Go. Now what we want to do is we want to interact with each of the documents by creating documents, retrieving, update, delete, all of that good stuff. So that brings us to CRUD. So create, retrieve, update, and delete. Now let's say that this is the kind of design behind our database and our collections. So we have a database maybe called Quick Start, and we have two collections, one called podcasts and one called episodes. And they hold each of the documents respectively. Now I told you in the previous slide that we'd get more into it when it came to that bson.m and then the empty brackets. So there's several MongoDB primitive types when it comes to the Go driver. So for example, you have the primitive.objectID. So if you ever don't want to create your own object ID and you want MongoDB to generate its own hash for you, that's what you would use. So this is the hashed object ID. There's bson.D, which represents a document. There's bson.m, which represents a map, and then A, which represents an array. Now, the big differences come around in the bson.D and the bson.m. So there are a lot of circumstances where the order of the fields within our bson matter. So if we're doing, say, a range query where we have to do a greater than or less than, something like that, the order of operations is going to matter in that sense. So we would probably be using a bson.d. If, for example, maybe we want to just retrieve a document, we can use bson.m. The order of the fields doesn't matter. Totally great. So you're going to have to use your own discretion when it comes to which one to choose. Now let's see how to use those. So let's take a look at the bson.d. This is when it comes to just a document and not necessarily a filter or query. So we create a bson.d. In this sense, is kind of like a key value kind of pair. So we have a title separated by a comma instead of a semicolon, for example, or a colon. And we have the actual value that goes with it. And we can do that for every field within our document. And it could get complex. So you can see the bson.a there. So we have tags being the field name, and then bson.a would be an array of string values. So this is perfectly acceptable. There's nothing wrong with it. When it comes to inserting, because maybe we don't have any data yet, we could insert that bson.d. So we would say podcast collection, which would be for podcast because that's what we've called it. We would say InsertOne. We'd provide a context with that timeout, so that way if it takes too long, we could stop it. And we would say bson.d in this example, and we would pass in that data that we just saw. If it errored for any reason, we would panic. Otherwise, in this case, what we're doing is we're saying, you know what, print out the ID of the document that was just inserted. And in this case, the ID is going to be an object ID, so a hash value. So it's going to return and print out that hash. It's not the only way to do business, though. We don't have to use bson.d when it comes to the Go driver for MongoDB and our documents. So the Go driver also offers bson annotations for our native Go data structures. So in Go, there's a lot of different opportunities when it comes to annotations. You could use JSON, XML, there's CSV, there's probably a ton of other ones as well. The Go driver for MongoDB gives us bson. So for this example, maybe we create a data structure called podcast. We give it each of the fields that we can use. In this case, ID is a primitive object ID, and we map them to particular document fields that would exist in the database. So for example, title in bson, even though that it matches title for the native Go data structure field, they can easily marshal and unmarshal between the different formats. The bson annotation doesn't need to match the field name. It's just coincidence and convenience that I've named them the same. Why might you want to do this versus the other way? So one reason might be when it comes to IntelliSense, so the autocomplete that you get in your editor. It's always a convenience to be able to type in some kind of variable name and then see what fields pop up when you're typing. So that way it's a convenience to you when it comes to figuring out what exists inside of that object. It's one reason. You won't get that in the bson.D, bson.m, things like that, because it's completely flexible. Another reason might be when it comes to error handling, or even just similar things around that. So testing. It's pretty hard to test when it comes to a completely flexible data format, but when you have a data structure, it becomes a little easier. I'm not saying you should choose one or the other. It's whatever makes the most sense to you, but you have options. Now, if we were using the native Go data structure approach, instead of saying bson.d when it comes to filling our variable, we would now use podcast because that's what's available to us, and we would separate it by the colons. So it's not too much different. It's kind of the same. There's an extra step of having to actually define that data structure, but again, there's options. Now, if we wanted to do the InsertOne again, this time with the Go data structure, well, first we're going to define that variable. We're going to say podcast collection.InsertOne, provide the context, which has our timeout and anything else, and then we provide podcast, which is our variable with that data structure. Same kind of results happen. We get the same thing back. We get an inserted ID, which we can print out. Now let's look at the insert many. So insert, update, find, delete. You're going to have options to do a one or a many. So they're all going to include this. They may be named slightly differently as we progress, but you're going to have some instance of both. So in this case, the insert many. So let's say that we say episodes collection.insert many. We provided a context. This time around, we provided a slice of interface. And basically what we're saying is we want to provide more than one document to be inserted in a single operation. In this case, we're using bson.d. We could use a data structure if we wanted to, but I'm just using bson.d in this example. If there is no error in the insert, then what we're doing is we are going to say, print out the number of inserted IDs. So we'll have access to basically a slice of inserted IDs that come back. So one for each of the items that we tried to insert. So in this particular example, I'm saying len and then that slice value. So I'm just getting the size and printing that out. So in this case, it would be 2 if it was successful. Now that we have the create done for CRUD, let's take a look at the retrieve, so the find. So find is going to return many rather than one. There's also a find one. But in this case, let's say that we want to use episodes collection.find. We provide the context, and then we provide bson.m, so a map, and this is our filter. So by default, if we provide nothing inside of our filter, it's going to return everything that exists in that collection. So just like what we saw when it came to listing the database names. However, this time around, I'm providing a duration and I'm saying 25. So this is an equality filter. So what I'm saying is we're only going to find documents for episodes that have a duration that equals exactly 25. Whatever that value is, it's got to be 25. If there was no error, we're going to create a slice of episodes. So let's say episode is a native Go data structure with all of the appropriate bson annotations. What we're going to say is we're going to say cursor.all, and we're going to load all of the results inside of this slice of episodes. So this episode's filtered. If there was no error, we're going to print out every single one of those episodes. Now, if you know your collection or your result set is going to be enormous, and I'm talking millions of documents here, something that would have a significantly bad effect if we tried to load everything into a slice at one time. We could always iterate over a cursor instead. So instead of saying .all, we could do that same query, but we can say for filter cursor.next. So filter cursor is just the variable that we chose to use for this cursor, but we can say .next and loop over our cursor in batches. So we're getting our result set a little bit at a time. And this will prevent loading massive amounts of data into our application at any given time. Now, should you be using one or the other? Well, that's up to you. It depends on how much data you have in your database or what you plan to do with it. So just note that there are two different ways that you can accomplish this. We won't look at the find one. It does exist. So let's just jump right into the update many. So update many in this circumstance, we're saying podcast collection.update many. Again, we provided the context. The first field that we look at is the filter. So bson.M, we're saying for any document that has a title that equals the Polyglot Developer Podcast. If a match is found, we're going to say bson.D, and we're going to set a field within those documents. So we're going to set a field called website, and we're going to include the website URL. Now, if that website field exists, it's going to replace that particular field with the new value. If it doesn't exist, it's going to add that field with the new value. So it kind of covers both kind of scenarios. There are other operators beyond set that you could use. It's totally up to you. There's some push commands to push items into arrays. There's a whole lot of good stuff in the documentation. Definitely take a moment to take a look to see what's available. If there was no error, in this case, we're saying, well, we've updated X number of documents. So we're getting the modified count from the result, and we're just printing it on the screen. Now let's look at the final part of CRUD. So we saw create, retrieve, update. Now we're looking at delete. Update many, there's also an update one. Just like with delete many, there's also a delete one. So we're going to look at delete many. In this circumstance, we're saying episodes collection. We're saying delete many. We are providing the context, and we're providing a filter. Again, these so far have always been very basic equality filters. So in this case, we're saying all documents that have a duration field that equals 25. But there's always the range filters and things like that you can use as well. Just consult the documentation to determine what kind of operation you want to do. So if there's no error, all we're going to do is we're going to say, show me the count for the deleted documents. So we return the deleted count, and we just print it out on the screen. So not too difficult. Overall, the CRUD operations when it comes to the Go driver and MongoDB, they're not so bad. There's not a lot to them. You can have very complicated queries. You can use the aggregation framework, things like that. But in essence, it's not so bad to use. It's quite easy. It's definitely not going to be the most difficult part of your application development. Now that we have a foundation to work with when it comes to CRUD, let's take a look at designing a REST API. So we're going to be looking at developing REST API endpoints, so that way client applications built in, say, maybe React or Angular can consume them. And this is pretty critical for the modern application. So you could use the Go net HTTP library if you wanted to create a web service in Go. Nothing wrong with that. However, there are some parts of that are a little more complicated than they should. Instead, there are other packages out there that are designed to make your life a little bit easier. So for example, the Gorilla Web Toolkit is one of my personal preferences. This is a multiplexer for Go. It basically makes it very easy to develop HTTP applications. It also offers a whole bunch of other nice features as well. So again, I'm using dep to keep consistency here. I'm saying dep ensure add, and then the Gorilla Web Toolkit. Once that's been added, what we can do is we can do the following. We could, assuming that we've already connected to MongoDB inside of our main function, establish a new router, and then define each of the endpoint paths, so the routes. So each route goes to a specific function, one that we haven't created yet. We also define the methods for that function. So whether that be put, which is common for create, get for retrieve, put for update, and delete for delete. So common when it comes to CRUD. As you can see here in this example, we're only working with podcasts. We're not worrying about episodes. Once we have those paths in place, we can hook up our router to a specific port and start serving it. Now, something you'll notice here, I do have a data structure called connection. Now, there's a hot debate going around when it comes to Go. Should you create a global variable with your database information, or should you pass that database information in to each of your functions? Rather than trying to decipher the debate, I've just decided to pass in that information to each function. So let's say that inside of that comment where I say MongoDB connection logic, let's just assume that I'm setting this connection variable, which includes my podcasts and episodes. and I am passing it into each function. Not so bad. Totally up to you what you want to do. If you want to create a global variable that could be accessed by any function without having to pass it in, it's totally up to you. So let's take a look at the create endpoint. So just like with CRUD, we're kind of doing the same thing when it comes to our API. And this might be a little alarming because it's longer. There's a lot going on when it comes to Go, but it really uses what we've already seen. So we have this function called CreatePodcastEndpoint. We're passing in the connection information. We have access to the response and the request. So first off, we're setting the response type. We want it to be JSON formatted. So common when it comes to REST APIs is the response going to be JSON, XML. Most commonly, it's JSON. Then we define the podcast variable. So what data are we getting from the request? How are we going to format it? And how are we going to insert it? So what we want to do is we want to use the decoder. We want to decode the request body. So this is what the user passes in. This is the payload. And we want to decode it into podcast, which has already been defined. Let's just say, assume it's been defined. It's a native Go data structure. It has our bson annotations. It has our JSON annotations. So that way, when we do our decode, it already knows how to process that data into an actual data structure. It's not too much different from what I showed you in the previous slide when it comes to bson. If it failed for any reason, we're going to return an error. It's already JSON formatted. We're going to return the message. If it didn't fail, we're going to set the timeout, and we're going to save connection.podcasts.insert1, and we're going to provide that podcast that we received. If that insert was successful, we are going to respond with the result. Now, in this example, we are not doing any kind of data sanitization, so we're just trusting whatever the user provides us. We're also not doing any kind of sanitization on the response. So we're just responding with whatever the database is telling us. In a realistic application, you're probably going to want to do data validation, and you're probably also going to return a different kind of response than what I'm showing here. Totally up to you, but this is more or less what you would get when you want to hit this endpoint for creating a document. Now let's take a look at the retrieve. So let's say we want to get numerous podcasts, hence the get podcasts plural. Same kind of setup. We set the response header. We create a slice of podcast because we know we're going to be getting more than one back. We say podcast.find. In this example, I'm saying bson.m, and that's empty for the filter. So I'm saying whatever exists inside of that podcast collection, let's return it. So that's everything. If there was no errors in this circumstance, we are going to use cursor.all, and we are going to take all of the results and put them in that podcast slice because, we're assuming that there's not that much data to work with. If you were working with large amounts of data, maybe you set up some kind of paging, so that way you get only a certain number of results back at a time. And in that case, you don't overload your application and cause it to be slow. We return with the podcasts that were taken from the database, and they are sent back to the client that requested them. Not so bad. The update. So again, not too much different from what we've seen so far. This is probably the more complicated of the requests, just because of how it works with HTTP and the Gorilla Web Toolkit. But we set our response header. This time around, we're going to get the variables from the route. So in a lot of circumstances, because we want to update a particular document, we generally pass in the ID in the URL bar. So we're getting that ID in theory through the parameters. We are turning it into a primitive type that MongoDB can understand. So we're wrapping it in that object ID from hex. So we're taking that ID and turning it into a proper object ID. We're creating our podcast variable. So this is what's going to be our payload, because remember, the user still has to provide the updates that they want to take effect. So we're taking what's in that payload, we're decoding it into that variable, and we're calling update1. Providing the context, we're providing it the filter. In this case, I'm saying, the ID has to match. We're in theory only going to be updating one document because we're using the update1 as well as the filter is a particular ID. And we're providing it the payload that we want to change. Now, a cool thing about this, because we're calling set and we're providing it the podcast payload that was provided, if you designed it this way, so if your native Go data structure and the bson annotations have the omit empty option, so if it's empty in the database, so if it doesn't exist, it won't exist inside of your Go data structure. So basically what we're saying is only update what the user provides. So this is pretty nifty. So if the user didn't provide a podcast name, but they've provided a duration, well, only the duration is going to be set or replaced. So that's pretty nifty. Now there's also a replace function. You don't have to use an update. So an update will do it on a per field basis, whereas the replace will replace the entire document. It's totally up to you. Assuming that this update goes correctly, we can respond with the result of that particular operation. This brings us to the delete podcast endpoint. So final operation as part of our API. This is just for the podcast endpoints, but we're getting the ID from the route parameters. We're turning it into a proper object ID. We're saying delete one if it's successful. So if we delete based on the ID, then return it as such in the result. So pretty much everything that you see, everything that you design when it comes to your API, it's going to be more or less the same. You're going to have, of course, like I said, or you should have at least data validation rules and maybe some better parsing of what you want the user to receive as a response. But beyond that, they should be pretty slick, pretty independent. You could add endpoints as you see fit, and they wouldn't cause much stress on your overall application. Now let's look at the GraphQL part. So this is not with REST, and I actually did sort of a bait and switch here. So when it comes to GraphQL, you could very easily create a GraphQL API in Go, similar to how we saw with REST. We could create our own resolvers, our own schemas, things like that, and be perfectly fine. However, what I'm going to show you, and then I'm going to show some Go code after it, I'm going to show you how to do this with MongoDB Realm. So with Realm, Realm has, at least right now it's beta, a baked in GraphQL functionality. So we can actually explore our documents using GraphQL. We can set up authorization rules. We can do all of that good stuff. So here's an example with GraphiOL. So this is a common tool that people use when it comes to GraphQL in general. So that's baked right into MongoDB Realm. So in this case, I have podcast. I'll show you how it maps to the particular fields in those collections, but I can create my query however I see fit. So here I would create a schema. So I would define what fields exist in my collections. So that way my GraphQL queries will actually function, or my mutations. I could easily create this manually, or I can say generate schema. So generate schema, what happens is you tell it what collection you want to use, how many documents you want it to analyze to get kind of a general schema from, and it'll do that for you. So it'll generate what I have here for you. Now, just because you are using GraphQL and you're making use of MongoDB Realm, it doesn't mean that you won't ever want to consume GraphQL in Go. It happens. Just like Go, you might need to consume REST APIs. So in this circumstance, maybe I create an authorization data structure with an access token. Because to use MongoDB GraphQL, you will need to have an access token. You will need to have been authenticated in order to use it. So in this circumstance, we say do a post request to the Realm API. So what's provided to you when you create your application. Get that access token and store it. So we're going to unmarshal it into our data structure. And then what we might want to do is we might want to use it on the next request. So let's say that we already have the access token and the logic. Now what we do is we create a GraphQL query. In this circumstance, I just created a JSON. So I created a map with a key being a string and a value being a string. I just modeled, so the key being the query, the value being the actual GraphQL query. What I did was I marshaled it. I made the new request. So to your Realm GraphQL URL, I included a header, which would be that access token. and I executed the request. And as a response, I should end up with the proper data that I requested. So this is a query. You're not receiving everything that exists in that collection or all fields. You are receiving exactly what you requested. So just the power of GraphQL. And again, we were able to do that with Realm. You don't have to do it with Realm, but it is available to you, which could cut out a lot of your development purposes. Now let's take a look at a quick demo, just kind of bring everything together. So up on my screen here, I do have MongoDB Atlas open. So I have my clusters. I'm going to look at the collections for this particular cluster. I have a quick start collection, or a quick start database. I have a podcast collection. This is what we saw inside of the slides. I'm just reiterating what we saw here. So we have these two documents. If I look at episodes, I should have maybe a few episodes in here. So these are our two collections. Not too different from what we've seen. Now, if I go into my editor, I do have an application open. So this application is actually the REST application that we saw in the slides. So I just wanted to show that there was no trickery. There's nothing going on. So for example, we have our data structures. We have a podcast. We have an episode, even though that we didn't see how to use it in the slides. They do have their annotations in place with omit empty. We have our connection created right here, so that way we can pass our connection information to each of the endpoints. But for example, create podcast, it's exactly what we saw. Nothing different here. Likewise with the get, the update, the delete, and then if we look at the main function, we have our connection logic to MongoDB. We're defining that connection object, and we are defining each of our possible paths, so each of our routes, and then we're hooking up the router. So if I were to run this, I can say go run main.go. I can go to a tool like Postman or whatever we feel comfortable with, and I can choose to make a new request. So I can say HTTP localhost 12345, because that was the host, podcasts, and I can say send. And this is the information that's coming back from our Go API. So this is our REST API. Hit the get podcast endpoint, and it returned us two documents here. Now, something to note here, something that I didn't actually do inside of the code, just to show you what happens when you don't do all of your JSON annotations or your bson annotations. Because I didn't add my JSON annotations, it just went with the name of the field for the data structure. So for example, inside of the code, if I scroll up here, I have podcast. I have a bson annotation, but I don't have a JSON annotation here. And the data that we're sending to our API is JSON format. So because of that, it's just taking the field name. If I wanted it to be custom, maybe I wanted it to be lowercase, or maybe in this case, the name versus title. If I wanted differences there, I would have to do the JSON annotations. So in order to make them match, totally up to you, whatever you feel best with. But I just wanted to throw it out there that was a thing. So if I go back into my slides, I want to talk about some closing thoughts here. So for example, like I said, the MongoDB driver supports bson mapping. That is probably one of my favorite features. While you could use bson.D, bson.m, things like that, I find that you make much better Go applications if you're using native Go data structures with those bson mappings. It's just personal opinion. It's not a requirement. You can do it however you feel the best doing it. But I just want to say that's out there. We saw how to do CRUD, but we didn't see how to use the data aggregation framework. We didn't look at chain streams. We didn't look at transactions. They're all supported with the MongoDB Go driver. API endpoints, they could be easily created. We saw how to do it with Gorilla Mux. You could use the very basic included with Go net HTTP package. They'd be similar, but there are some differences that make Gorilla Mux, so the Gorilla Web Toolkit, a little easier to use. And then when it comes to GraphQL, you could definitely use MongoDB Realm. You could definitely develop it yourself. Developing a GraphQL API in Go, it's not too different from developing a REST API, but it does involve actual maintenance and like actual labor on working on it. So using MongoDB Realm is an option. If you want more help on this, visit cloud.mongodb.com. You can reach out to me on Twitter. It's nraboy, so Nick Raboy, nraboy, or MongoDB on Twitter. Also, I just wanted to put it up there one more time. If you haven't already used this promo code and you want to sit on some credit because you feel like you might in the future need a more premium cluster, go ahead and use it. So Nick Raboy 200 will get you $200 in credit. My gift to you. Thanks for tuning in.